Welcome back to my channel RV Maths Academy. Before watching this video, make sure that you have watched part 1 to part 5 of Introduction to Trigonometry. In this video, we are going to study the trigonometric ratios of the complementary angle. Watch this video till end to clear your concepts. Now, do you know what are complementary angles? Yes. Complementary angles are those angles whose sum is 90 degrees. So first we are going to just develop a relation between the trigonometric ratios of complementary angles. We know that the trigonometric functions have a special relation with the complementary angles. So first we are going to study it with the help of a super hexagon trick. So this is a super hexagon. We all are familiar with this because we have learned in the second video about the super hexagon. So first what we have to do, we have to just give the position of the trigonometric ratios. This is tan, sine, cos, this one is cot, this one is cosec, this is sec. Because it is very important to remember the position of all these trigonometric functions or ratios in this super hexagon. Now what we have to do, first we just put an arrow in this direction. So what does this arrow represent? This arrow represents sine of angle theta is equal to cos of complement of this angle. Complement of this angle means 90 degree minus theta. Now, similarly, if I just take tan to cot, if I just move in this direction from left to right, we can write tan theta is equal to cot of 90 degree minus theta. Similarly, for third, if I put an arrow in this direction, we can write sec of theta is equal to cosec of 90 degree minus theta, which is the complement of this theta. Now, what happens if I just put an arrow in the opposite direction? So if I put an arrow in the opposite direction, means from cos to sine, suppose if I'm putting the arrow in this direction, then I can write it as cos of theta is equal to sine of 90 minus theta. Similarly, if I put an arrow in this direction from right to left, then again I can write it as cot of theta is equal to tan of 90 degree minus theta. Similarly here, if I put an arrow in this direction from right to left, I can write cosec theta is equal to sec of 90 degree minus theta. So through this super hexagonal trick, we can learn all these formulas. This is the first, this is the second, this is the third, fourth, fifth, and sixth. So in this manner, we can learn the trigonometric ratios of complementary angles. Now this is the relation which I have explained you through a trick. Now how do we derive it? So let us consider triangle. This is a 90 degree. Let this angle be theta. We know that in the right angle triangle, if this angle is 90, it means the sum of remaining two angles will be 90 degree. So if this is theta, then it will be 90 degree minus theta. So this angle will be 90 degree minus theta because they are complementary angle. Because if this angle is 90 degree, the sum of these remaining two angles will be 90. So it means if this angle is theta, then this angle will be 90 degree minus theta. Now we can name this triangle as A, B, and C. So these are the relations which we have learned. Now, how do we derive it? So first I will write sine theta. How do we derive it? Now sine theta. So we know that the formula of sine is perpendicular upon hypotenuse. If I'm considering this angle theta, then the perpendicular is the side just opposite to it. So we can write sine theta is equal to perpendicular, that is BC, upon hypotenuse. Hypotenuse is the side which is just opposite to 90 degree. So this side is just opposite to 90 degrees, so we can write it is AC. Now, similarly write the formula of cos theta. Cos theta is base upon hypotenuse. If this is perpendicular, so AB is the base. So we can write AB upon hypotenuse, that is AC. Now tan theta. tan theta is equal to perpendicular upon base. So this is a perpendicular, so we can write BC upon AB. Now, we can write cosec theta. Cosec theta is just reciprocal of sine, so we can write it as AC upon BC. Similarly, sec is the reciprocal of cos, so we can write it as AC upon AB. Similarly, cot is the reciprocal of tan, so we can write it as AB upon BC. Now, we have written all these 6 trigonometric ratios with respect to this angle theta. Now the same I will do, but with respect to of 90 degree minus theta. So again I will write all the 6 trigonometric ratios, but with the help of this, by considering this angle 90 degree minus theta. So first we will write sine 90 degree minus theta. So if I am considering this angle, so the side opposite to it will be perpendicular. So this side AB is just opposite to 90 degree minus theta. So I can write sine 90 degree minus theta is equal to AB. This is the perpendicular. Hypotenuse is always fixed because it is always opposite to the 90 degree. So this is AC. Now, cos 90 degree minus theta. This is base upon hypotenuse. So if this is perpendicular, so BC will be the base because I am considering the angle 90 degree minus theta. So hypotenuse is AC. Now, next is tan 90 degree minus theta. So tan 90 degree minus theta is, this is tan 90 degree minus theta. So this, the side just opposite to this angle because I'm considering 90 degree minus theta. So this side is a perpendicular, which is AB, and the base, which is BC. So I can write AB upon BC. Now the fourth one, that is sine, I have written cos, tan. Now next one is cosec. So cosec 90 degree minus theta. So we know that this cosec is a reciprocal of sine. So we can write cosec 90 degree minus theta is equal to AC upon AB. Now we can write sec 90 degree minus theta. So sec 90 degree minus theta. Now sec is the reciprocal of cos. So we can write it as AC upon BC. Because cos 90 degree minus theta is BC upon AC. So sec 90 degree minus theta is equal to AC upon BC. Now, cot 90 degree minus theta. So cot 90 degree minus theta is, now cot is a reciprocal of tan. So tan 90 degree minus theta is AB upon BC. So we can write it as BC upon AB. Now, you can see here that this sine theta is equal to BC upon AC, and this cos 90 degree minus theta is equal to BC upon AC. So we can see this one, this sine theta and this cos 90 degree minus theta, they are same because sine theta is equal to BC upon AC and cos 90 degree minus theta is equal to BC upon AC. So it means we can write cos 90 degree minus theta is equal to sine theta. So we have got this relation. Now come to the cos theta. Cos theta is equal to AB upon AC, and you can see sine 90 degree minus theta is equal to AB upon AC. So we can see AB upon AC is written here. Similarly, AB upon AC is written here. But here it is a value of cos theta, and here it is a value of sine 90 degree minus theta. So we can write sine 90 degree minus theta is equal to cos theta. So this is sine 90 degree minus theta is equal to cos theta. Now similarly, you can see cot theta is AB upon BC, and tan 90 degree minus theta is equal to AB upon BC. So we can see here that tan 90 degree minus theta is equal to this cot theta. So this relationship we have got. Now next we can see this is the cot 90 degree. This is 90 degree. Cot 90 degree minus theta. This is BC upon AB, and this is tan theta. This is BC upon AB. So we can write cot 90 degree minus theta is equal to tan theta. Similarly, sec 90 degree minus theta. You can see sec 90 degree minus theta is AC upon BC, and cosec theta is equal to AC upon BC. So they are same. So we can develop this relation, sec 90 degree minus theta is equal to cosec theta. Now the next one is cosec 90 degree minus theta, which is AC upon AB. So you can see here sec theta is AC upon AB. So we have got this 6 relation. So in this manner, we have got all these 6 formulas. Sin 90 degree minus theta is equal to cos theta, cos 90 degree minus theta is equal to sin theta, tan 90 degree minus theta is equal to cot theta, cot 90 degree minus theta is equal to tan theta, sec 90 degree minus theta is equal to cosec theta, cosec 90 degree minus theta is equal to sec theta. Now we are going to do some questions on this trigonometric relation of the trigonometric ratios with the complementary angles. And most of the time we get the questions in the board examination from this concept. So there are 2 questions first we are taking. Now sin 18 degree upon cos 72 degree. How do you know in the examination, how do you come to know that whether these questions are based on this formula complementary angles or not? First, what we have to do, first add these 2 angles, 18 and 72. If you add 18 and 72, what will you get? 18 degree plus 72 degree. If you add, you will get 90 degree. It means we can solve these questions with the help of the trigonometric relation of the trigonometric ratios with the complementary angles. So we can write, we know this formula that sin 90 degree minus theta. We know that sin 90 degree minus theta is equal to cos theta and cos 90 degree minus theta is equal to sin theta. Now what we have to do, you can change any one, either numerator or denominator, it's up to you. You can change any one. So here I'm changing the numerator. So I can write sin 18 degree is equal to, now you have learned this formula, sin theta is equal to cos 90 minus theta. Theta is written here. So here you will write theta. So here my theta is 18, so I can write it as cos 90 degree minus 18. Because sin theta is equal to cos 90 degree minus theta, and theta is 18 in my question. Now, when you just subtract them, 90 minus 18, what will you get? You will get 72 degree. Now what we have to do, we have to put the value of sin 18 degree in our expression. So we can write sin 18 degree upon cos 72 degree is equal to, now put the value of sin 18 degree, which is cos 72 degree. This is cos 72 degree. If you cancel out, you will get 1. So the value of this expression is 1. One more thing is there, you have to keep in your mind, if you are changing this trigonometric ratio, please make sure you will not change this value. If you are changing this sign, here is the trigonometric ratio is sine, and here you have written cos. So at a time only you will change only one thing. Either you will change the value or you will change the trigonometric ratio. If you are changing trigonometric ratio, then don't change this value. And if you are changing this value, then don't change the trigonometric ratio. This is a second method. I'm just giving you a hint. Only I'm giving you a hint here. If you don't want to change the this trigonometric ratio, if you want to write, you can also write it sin 18 degree is equal to sin 90 degree minus 72 degree. Because if I subtract 72 from 90, I get 18. So sin 18 degree can also be written as sin 90 degree minus 72 degree. Here I have not changed the trigonometric ratio. Here I have changed the angle. So at a time only you can change one thing, either change the trigonometric ratio or change the angle. Here I have changed the trigonometric ratio. This is sine, this is cos. So I have not changed the value. 18 is written here, 18 is written here. Here I am changing the trigonometric, here I am not changing the trigonometric ratio. So I am changing the value. I have written 18 here, so I have written 72 here. So at a time you can just write only one thing. So sin 90 minus 72 means cos 72. So again you will get the same thing. Sin 18 degree is equal to 72 degree. Here you have got, and similarly here also you have got sin 18 degree is equal to cos 72 degree. So any method you can follow in the examination. Now, again we will write the formula first. tan 90 degree minus theta is equal to cot theta, and cot 90 degree minus theta is equal to tan theta. So first we have to check whether 26 degree and 64 degree. You can see here they are forming a complementary angle. So definitely we will apply the formulas of complementary angles here. So again you can change any one, either numerator or denominator. So first I am writing tan 26 degree as 10. If I'm not changing the trigonometric ratio, it's up to me. So I can write 90 degree minus 64 degree. Here I'm not changing the trigonometry. It's up to you. If you want to change the trigonometric ratio, you may change the trigonometric ratio, but at that time you will not change this value. You will write 26. So 10 90 minus 64 means cot 64 degree. So I can write tan 26 degree upon cot 64 degree is equal to, I will put the value of tan 26 degree, that is cot 64 degree upon cot 64 degree. If I cancel it, I will get 1. Or second method, again I'm giving hint. If you don't want to change the trigonometric ratio, if you want to change the trigonometric ratio instead of value, what we have to do, you will write tan 26 degree is equal to cot, because tan theta is equal to cot 90 minus theta. So theta will remain same. So I can write cot 90 degree minus 26 degree. So this I can write cot 64 degree. So again I'm getting the same thing. So it's up to you which one you want to change. You want to change the trigonometric ratio or value, but the answer will remain same in every case. Now the next question. So what we have to do, first I'm going to just take this cos 48 minus sine 42. So first I have to check whether the sum is coming 90 degree or not. So here you can check the sum is coming 90 degree. It means we can apply the formula of trigonometric ratios of the complementary angles. So we know that sine 90 degree minus theta, we can write say sine 90 degree minus theta is equal to cos theta, and cos 90 degree minus theta is equal to sine theta. So what will happen? In this time we can change only one. Either you will change the first term or the second term. Answer will remain same, but at a time you will change only one term. So here I am changing cos 48 degree. So cos 48 degree can be written as, now cos theta is equal to sine 90 minus theta. So I can write sine 90 degree minus 48. So sine 90 degree minus 48 means sine 42 degree. So I will write cos 48 degree minus sine 42 degree is equal to, now put the value of cos 48 degree, that is sine 42 degree minus sine 42 degree. So when I just cancel them, I will get 0. So the value of this expression is 0. Now come to the next. Again, first we'll write the formula. Cosec 90 minus theta is equal to sec theta, and sec 90 degree minus theta is equal to cosec theta. Now, first, any one of these terms you can change, but you will change only one out of these two. You will not change both the terms together. So at a time you will change only one. So here I am changing cosec 31. So cosec 31 degree is equal to, we can write cos. So here you can write cosec is equal to sec. So either if you want to change this trigonometric ratio, so you can write sec 90 degree minus 31 degree. So we can write, this is sec 59. Now we will write cosec 31 degree minus sec 59 degree is equal to, now put the value, this is sec 59 degree minus sec 59 degree. Now we cancel out. You will cancel out and you will get the value of this expression as 0. Now come to the next question. In this question, you have to show that tan 48 degree, tan 23 degree, tan 42 degree, tan 67 degree is equal to 1. So first, what we have to do, first we have to find the angles whose sum is 90 degree. Now you can see here, if you take 48 and 42, they are making 90 degree because 48 degree and 42 degree. If you just add them, their sum is 90 degree. Fine. So their sum is coming 90 degree. Now, if you just take 23 degree and 67 degree, then again you can see the sum is 90 degree. So what we have to do, first we will just write those angles, those trigonometric ratios together whose sum are making complementary angles. So I will write tan 48 degree and tan 42 degree together. And here I am writing tan 23 degree and tan 67 degree together. This is the left hand side. Now, as I have already explained you, the angles which are making sum 90 degree, or you can say which are complementary to each other, on those angles I will change only one of them. So either I will change 48 or I will change only 42. Any angle I can change, but it will not affect my answer. So I'm changing tan 48 degree. So here we know that first we'll write the formula tan 90 degree minus theta is equal to cot theta, and cot 90 degree minus theta is equal to tan theta. So first I will write tan 48 degree. So tan 48 degree I can write tan 48 degree, I will write it as cot 90 degree minus 48 degree. Because tan theta is equal to cot 90 minus theta. And cot 90 minus 48 means cot 42 degree. Now, similarly, from these two angles, tan 23 and tan 67, I will change any one. So here I am changing tan 23 degree. So tan 23 degree can be written as cot 90 degree minus 23 degree. So I can write cot 67 degree. Now, what we have to do, we have to put the value of all these in the given expression. So here I will write tan 48. So I will put the value of tan 48. This is cot 42. So I will write cot 42 degree, tan 42 degree. Now put the value of tan 23, which is cot 67 degree. This is cot 67 degree, tan 67 degree. Now, we know that since tan theta and cot theta are reciprocal of each other, so we can write tan theta is equal to 1 upon cot theta. So I'm using this relation, so I can write cot 42 degree. This can be written as 1 upon cot 42 degree. Now cot 40, this is cot 67 degree into 1 upon cot 67 degree. Now if you just simplify them, you will get 1. And this 1 is nothing but the right hand side. Now in this question we have to prove cos 38 degree, cos 52 degree minus sin 38 degree, sin 52 degree is equal to 0. So what we have to do, first we will write the formula. We know that cos 90 degree minus theta is equal to sin theta, and sin 90 degree minus theta is equal to cos theta. Now we know that here that 38 degree and 52 degree, if I add them, I will get 90 degree. It means these two angles are making a sum of 90, or you can say these two angles are complementary. Similarly here 38 and 52, if I add them, they can make a sum of 90 degree. It means they are complementary angles. So there are two terms. First term is cos 38 degree into cos 52 degree, and the second term is sin 38 degree into sin 52 degree. So in each of the term, I will change any one of them. Either I will change cos 38 degree or cos 52 degree. So we can write cos 38 degree. So we can write cos theta is equal to sin 90 minus theta. So I can write it as sin 90 degree minus 38 degree. So sine 98 degree minus 38 degree means what you will get sine 52 degree. Now, here you will get sine 52 degree. Cos 38 degree is equal to sine 52 degree. Fine. Sine 52 degree is already present here. So it means again I will change this sine 38 degree, not this one. So sine 38 degree. Sine 38 degree to sine theta can be written as cos 90 degree minus theta. So we can write it as cos 90 degree minus 38 degree. So we can write it as cos 52 degree. Now we will put the value in the left hand side. So if I put the value, I will get cos 38 degree, that is, put the value of cos 38 degree, that is sine 52 degree. First I will write cos 38 degree, cos 52 degree minus sine 38 degree, sine 52 degree. Now this will be equal to, put the value of cos 38, that is sine 52 degree, cos 52 degree. Now put the value of sine 38, that is cos 52 degree. This is sine 52 degree. So these two terms will cancel out because they are the same term with opposite sign, sine 52 degree into cos 52 degree, and this is also cos 52 degree into sine 52 degree. So when you simplify, you will get 0, and which is equal to the right hand side. In this question, if tan is equal to cot A minus 18 degree, where 2A is an acute angle, we have to find the value of A. So what we have to do, first we will write tan theta is equal to cot 90 degree minus theta, because we have learned this formula. And one more formula we have learned, that is cot 90 degree, or you can say cot theta is equal to tan 90 degree minus theta. Now, in this question, you can change any of the side, either if you want to change the left hand side or you want to change the right hand side, any one of the side you can change, but don't change both the sides. So if we are changing the left hand side, so tan theta is equal to cot 90 degree minus theta. So we can write tan 2A is equal to cot A minus 18 degree. This is our question. So since tan theta is equal to cot 90 degree minus theta, so we can write the left hand side. If I am changing the left hand side, so we can write it as cot 90 degree minus 2A. This is equal to cot A minus 18 degree. So on both the sides, we are having same trigonometric ratio. So we can write 90 degree minus 2A is equal to A minus 18 degree. So bring 18 degree on the left hand side. So you will write 90 degree plus 18 degree is equal to A plus 2A. So when you add, you will get 108 degrees equal to 3A, or A is equal to 108 degree upon 3, or you can write 36 degree. So we have got the value of A, that is 36 degree. Now, if in place of 10, if you want to change the right hand side, this is the first method. If we change the right hand side, then see how we will do it. So we can write it as tan 2A. Now, cot theta can be written as tan 90 degree minus theta. So here theta is A minus 18. So we can write it as tan 90 minus. Now in place of theta, I will write A minus 18. Because my theta is A minus 18 degrees, so I will write A minus 18 degree here. Now, we can write it as tan 2A is equal to 10. Now, according to Bodmer's rule, first we will open the small bracket, that is minus A plus 18. So when you solve it, you will get 10. 90 plus 18, that is 108 degree plus, this is minus A. This is minus sign. Now this is tan 2A. Now here you are getting same trigonometric ratio on both the sides. So we can write it as 2a is equal to 108 degree minus a. So when you bring on this side, you will get 2a plus a is equal to 108 degree. Or you can write 3a is equal to 108 degree, or a is equal to 108 degree by 3. So you can write a is equal to 36 degree. So whether you are changing the left hand side or right hand side, the answer will remain same. Now come to the next question. If tan A is equal to cot B, prove that a plus b is equal to 90 degree. So we know that tan theta is equal to cot 90 degree minus theta, and cot theta is equal to tan 90 degree minus theta. So again, we can change any of the side, either left hand or right hand. Please remember, we cannot change both the sides. We can change only one side, either the left hand side or the right hand side. So we can write tan A. We can write, this is our question, tan A is equal to cot B. So if I'm changing the left hand side, so I can write it as cot 90 degree minus, in, in place of theta, I have to write A. So this is 90 degree minus A is equal to cot B. Now we are getting the same trigonometric ratio on both the sides. So on comparing, we can write 90 degree minus A is equal to B. So bring this A on the right hand side, this is negative, so it will become positive. So we will get A plus B is equal to 90 degree, and that we have to prove. You will get the same result if instead of the left hand side, you change the right hand side. Now, come to the next question. If sec 4a is equal to cosec A minus 20 degree, where 4a is an acute angle, find the value of A. So again, we have learned this relationship. Sec theta is equal to cosec 90 degree minus theta, and cosec theta is equal to sec 90 degree minus theta. Now our question is sec 4a is equal to cosec A minus 20 degree. Again, what we have to do, we have to change any one of the side, either left hand side or the right hand side. So here the left hand side is a very short one, so I prefer to just change the left hand side. Otherwise, you can change the right hand side also. In both the cases, you will get the same answer. So here, we know that sec theta is equal to cosec 90 minus theta. So in place of theta, it is 4a. So I can write it as cosec 90 degree minus 4a is equal to cosec A minus 22. Now here I am getting the same trigonometric ratio. So I can write 90 degree minus 4a is equal to A minus 20 degree. So now bring the constant term on one side and the variable on the other side. So I can write 90 degree plus 20 degree is equal to A plus 4a. So this is 110 is equal to 5a. So if you divide it, what will you get? 110 degree upon 5. So you will get 22 degrees. So the value of angle A is 22 degrees. Now the next question. If A, B and C are the interior angles of a triangle ABC, then show that sine B plus C upon 2 is equal to cos A by 2. This is your question. This is your complete question, cos A by 2. This one you have to prove. Now, what we have to do, this is your solution. We know that the sum of three angles of a triangle is 180 degree. This is the angle sum property. This is we know. We know that the sum of three angles of a triangle is 180 degree. So if interior angles are A, B and C, then we can write angle A plus angle B plus angle C is equal to 180 degree. Now you can see in this question that this is B plus C. So I will write B plus C on one side and I will bring A on the right hand side. So this is positive. So when I bring it on the right hand side, it will be negative. Now you can see that it is written B plus C upon 2. So what we have to do, we will divide both the sides by 2. Now what we will get? We will get B plus C by 2 is equal to, now 180 degree by 2. We can write 180 degree by 2 minus A by 2. So we will get B plus C by 2. This is 90 degree minus A by 2. Now what we have to do, you have to write your, because sine is written along with B plus C by 2. So taking sine on both the sides, you will get sine B plus C by 2 is equal to sine 90 degree minus A by 2. So we will get sine B plus C by 2. Now sine 90 degree minus theta is cos theta. So we can write cos A by 2, which we have to prove. So this is equal to the right hand side. So that we have to prove. Now in this question we have to write, we have to express sine 67 degree plus cos 75 degree in terms of trigonometric ratios of angles between 0 degree and 45 degree. So we know these relations. Sine theta is equal to cos 90 degree minus theta, and cos theta is equal to sine 90 degree minus theta. We know these two relations. Now we can write our expression sine 67 degree plus cos 75 degree is equal to, now sine theta is equal to cos 90 minus theta. So we can write it as sine 67 degree is equal to cos 90 degree minus 67 degree plus, now cos theta is equal to sine 90 minus theta. So we can write cos 75 degree is equal to sine 90 degree minus 75 degree, because our theta is 75 degree here. So when you subtract 67 from 90 degree, you will get 23 degree. So we'll get cos 23 degree plus 90 minus 75 is 15. So we'll get sine 15 degree. So here we have got an expression in which angles are lying between 0 and 45 degree, because 23 and 15 both are lying between 0 and 45 degree. So this is all in today's videos. I hope you have liked my video. In the next video, we will discuss the trigonometric identities. And till then, goodbye. Thank you for watching this video. If you like this video, then please give a like to this video. Share with your friends and subscribe this channel.